Hello and welcome to this week's lecture on the topic of attention. Now, for this week we are going to focus on the way that we attend to and encode faces. And why are we interested in faces? Well, primarily because they are the most social of stimuli that's out there. And we're going to focus on the way that faces can direct our attention, primarily through other people's eye gaze. We're going to focus on face perception, so extending from some of the kind of basic knowledge that you might have understood about how we process different parts of the face. We do this in a sort of holistic manner. We're going to extend on some of that knowledge in this lecture. And we're also going to spend a lot of time looking at the inferences we can make from people's faces. So when you see somebody, what are the judgments that you make about this person's character and personality traits? What makes you think that this person's likely to be friendly or this person's likely to be trustworthy, etc. So to say, faces are the most social of stimuli that's out there. And this is where we're going to start and spend most of our time. Some of the insights into the fact that faces are social stimuli. We see that newborns So the importance of faces as something that will kind of naturally grab our attention can be illustrated by the fact that newborns have a sort of strong disposition towards preferring to look at faces compared to objects. So if you were to show a newborn baby a person's face and give them an object, the place that they would typically direct most of their attention and their time is towards the face as opposed to the object. And this, from an evolutionary point, makes sense as well. That if you're dependent on other people for your survival, it would make sense to be able to orient your attention towards, with the idea of learning to recognize and attend to caregivers. We also find that faces are something that naturally gain our attention. So if you're looking at a scene or an image on here, typically the first thing that your face gets drawn to is the people's faces. So there might be some periphery and detail. So despite the kind of vividness of what's on the screen here, most of you would orient to these people's eyes and maybe the kind of smiling mouth first of all, before you then start to look at any of that background detail that is there. You look at the smiles rather than necessarily looking at the detail on the t-shirt to start with. Faces is also really sort of essential for us being able to interact with other people. So having accurate face detection when I see somebody, being able to recognize who they are and put a name to them is really important. And if you imagine a world where you're not able to do this and you're just walking around and everybody is kind of largely anonymous to you, it would be a much more challenging social environment to navigate. So we find it is sort of critical in this ability to successfully function in social situations. And finally, faces can be a very important, or can serve a very important function of directing attention. So particularly through our eye gaze, we can direct the attention of others and our attention can be automatically drawn towards where other people are looking at. So let's look into a little bit of the literature on eye gaze detection. So most of the time when you're in conversations with other people, the eyes are what we spend our time looking at. It's where most of our attention and our focus typically goes towards. So if you're in conversation with somebody, the active part is somebody's mouth that's moving. But despite that, we obviously look at somebody's mouth, but we often draw most of our attention towards their eyes. And we can use this to signal things like turn taking. So there can be indicators of when somebody is about to finish talking by the way that they look. We can use it to read emotions. So we can see fear, anxiety, happiness, and we can use them finally to work out what another person is looking at. And this is something that we are, as humans, very highly adapted for gaze detection. So being able to understand where somebody's focus of attention is with their eyes. And one of the reasons we can do this quite well is that compared with other primates, humans have a relatively small dark region, so the pupil and the iris, and comparatively large regions of white sclera to either side of the pupil and the iris. And the benefit of this is that it makes the discrimination of eye gaze direction much easier in humans than animals. That's not to say it's impossible in animals, but if you compare trying to watch where a monkey is looking at compared to where a human is looking at, we seem to be much better with humans. Now, how good are we? If you wanted to define the accuracy of eye gaze detection, there's some original early work by Gibson and Pick that showed that participants' threshold for accepting truly deviated gaze as direct gaze is 2.8 degrees. Now, what on earth does that mean? What that means is if you were to look off by 2.8 degrees to the side of somebody, anything further than that and somebody would judge you as not looking directly towards your eyes. You would notice that somebody is kind of deviating the eye gaze. So somebody needs to be looking almost directly at you for you to perceive, or if it's a little bit to the side, we can notice that. There are also more recent studies that use somewhat more robust methodology here to study the accuracy of eye gaze detection. For example, Bock et al. Would run a study here where they had computer simulated images of people that were directing their gaze towards objects that were located around a sort of 360 degree visual field. And the job of the participants was to guess where do they think these objects are located based on the person's eye gaze towards them. And it turns out that people's gaze detection is really robust and highly accurate. So we know that we are very accurate with detecting other people's eye gaze. Why would this be important? So why, just as a general process, why would it be useful to orient your attention to where people's eye gaze is directed? And the most fundamental reason is that other people's eye gaze signals their intent. So it often signals where their attention is directed towards and what they have some intention to typically interact with. So people look at objects and others with whom they have some kind of intention to interact with. Now let's look at one example that's illustrated here. So this is a Dutch painting by the artist Juho Rijsanen, and it shows the heat map of gaze direction during 10 seconds of somebody free viewing. So in this case there were 20 participants that have taken part in this bit of research here, and the heat map illustrates the frequency or the amount of time that is directed to different locations on the image. So the darker that colour, so the more red the colour, the more time that has been spent focused on that particular location. And the painting here shows two men that are facing each other that are lighting their pipes. And one of the things that you pick out from this is, first of all, is that people stare at the two faces. But then where they're most strongly drawn towards is where the men are gazing in the middle. So this bit where they're gazing towards the lighting of their pipes. You'll also notice down there that the other area that people direct their attention to is the name of the painter. It's obviously important to find out if this is a famous artist and whether you should care about it or brag to your mates and put it on Instagram. I'm joking. So we look at other people, but we principally look at where they're directing their attention towards after that. You might also argue that in this particular instance there's some sort of ambiguity about the object that's at the middle, so maybe people also spend more time directing their attention there just because they're trying to understand what this object exactly is. Okay, let's stop and think for a second. Can you come up with any situations, circumstances where you think eye gaze direction is potentially very important. Is there any domains in real life where you think it's really relevant that we're accurate with our eye gaze detection, or where you might use eye gaze detection to trick or manipulate somebody else? And then after you try and think of any examples, can you also think of any instances in marketing where you could apply this knowledge to, for example, improve the impact of an advert? So pause the video and have a quick think. Okay, so let's look at an illustration of how eye gaze might influence the way that we end up processing two advertisements. They only have one subtle difference here. So if we look at the image on the left hand side, so this is advertising a bunny foot shampoo. I do not know if this is actually a genuine shampoo or not. But in the first one, you've got this attractive redhead that's looking directly towards the camera. And I think many of us would maybe intuitively, if you're designing an advert, you might think that, yeah, there's something appealing about this. And this would be a pretty standard, good advertising strategy. Whereas alternatively on the right hand side, we instead have the model, their eye gaze is now directed towards the product, the shampoo that you're trying to sell. And if we look at how, again, if we're looking at the visual heat maps here of where people's attention, so visual attention, is directed, on the left hand side you get a lot of attention directed towards the eye, and then a moderate amount towards the product, and also the product name. And I think the thing that is then striking on the right hand side is that you can see the fact that this attention has been directed from the eye straight towards the shampoo product, and there's more time and more focus, only a little bit more that's focused towards the product there. So that's one nice example of how you could essentially manipulate or direct somebody's attention around that advert in a way that corresponds with where you want them to look at. Another example, we've got two adverts here of a baby that's looking towards you as they're advertising diapers for sensitive skin. Again, in this one, most people's attention goes directly towards the baby's face. That's what you would expect. That's where our attention is naturally drawn. If we now turn around the direction of the baby's eye gaze and have him now focusing his attention towards the text and the information that's there, we can see most people firstly would direct their attention towards the baby's face, but they would then shift their attention much more strongly towards the direction where the baby is looking himself. So we know that it's not just human eye gaze that can influence and direct our attention, animal eye gaze can do it as well. So an example of animal eye gaze behavior that's on here, that's in a much more experimental setting, we can see that if you cue people with animal eye gazes, this can cause them to direct their attention to the location where the animal is looking. So if we look at this experimental setup on the screen here, you should be familiar with when we've got these boxes depicting the sort of flow of an experimental trial. What we're seeing here is what's presented on screen for particular intervals of time. So in this case, we've got a fixation cross that appears for the first 500 milliseconds. This is followed by the presentation of a tiger that looks directly towards you. That's for 500 milliseconds. And then the tiger would direct its eye gaze towards either the left or the right hand side of the screen. And then after another 500 milliseconds, a target would appear on the left or the right hand side of the screen. So in congruent trials, the target's going to appear in the same direction as where the tiger's eye gaze is directed. Incongruent trials, it would appear in the opposite location. And you find very convincing, robust effects from this, that people are much faster at responding when the target appears in the location that's congruent with the tiger's eye gaze. And that's a pretty strong indicator that our attention is being directed in the location where the tiger is gazing towards. It's also the case that this is a largely automatic process. So we're automatically drawn to focus on eye gaze as an informational cue. So even if we know that it's not necessarily going to be informative, or it might disadvantage our performance on the kind of current task or the goal that we have, we still seem to follow other eye gaze detection cues here. So how do we know that our attention is automatically drawn by eye gaze? Well, one way to show this was done by Galfano et al. In a nice study where they told participants with 100% certainty the future location of an upcoming target. So in this study, you are presented with fixation cross at the start, and then you're presented with a word information. In this case, because it's done in Italy, the word destra means to the right. So you're told that on this trial, the target is going to appear on the right-hand side of the screen. Now, as you're doing this experiment, you have two response keys that would indicate this is a response from the targets on the left, this is the response on the right. So you should be right now thinking, as soon as that target appears, all I've got to do is just press this right response key. And I want to keep my attention on the right-hand side of the screen. However, the interesting effect that they found in these studies is if you then presented a face that is directing its eye gaze towards the left or the right of the screen, this should be an irrelevant, uninformative cue. So as you're doing the study, you should be ignoring any of the information or any of the distraction that comes from the presentation of the face that's looking to, in this case, to the left-hand side of the screen. But the problem is people don't seem to ignore it. So their reaction times are slower when that face is directed towards the opposite location, so the incorrect location where that target isn't going to appear. Whereas they would be faster to respond on trials where it's congruent and the eye gaze is directed towards where that location of the target is going to appear. So it seems to be the case that there is some automaticity, that we're automatically drawn to be influenced in our attention by these faces with eye gaze, even though we know in this task we should be ignoring it, we shouldn't be paying attention to it. And interestingly, you get the same effect if you give these arrow flankers that are appeared here. So if you have an arrow that points towards the left-hand side, similarly our attention is automatically drawn by that, and people are slow at responding to targets that they know that they should know that are going to appear in the opposite location. Okay, so what are some of the neural correlates of eye gaze perception? And we've got converging evidence that the superior temporal sulcus appears to be absolutely critical in eye gaze. So some of the early evidence comes from single cell recording in primates. So if you insert an electrode and record single groups of cells, you find that there's a lot of activity in the superior temporal sulcus when primates are looking at other primates, directing their eye gaze towards different locations. Similarly, from fMRI studies in humans, we get strong activation across this region. There's also evidence from neuropsychological studies of patients with lesions. So for example, patient MJ is someone who had a lesion of the superior temporal gyrus, and for this patient they really struggled with maintaining eye contact. They also showed impairments of the gaze cueing effect. So that study we've just looked at, where you would see a faster response time to targets that appear in the location where you've just been cued or primed with a gaze towards, they don't show this effect. They don't show a faster response time on congruent trials. But they do find that arrows, so if you have an arrow that points towards the right or the left, this would make the patient faster at responding to the cue that appears in a congruent location. And what that indicates is this region around the superior temporal sulcus and superior temporal gyrus is doing something that is unique to the detection of eye gaze, as opposed to just the processing of directional or attentional cues and information there.